So first of all, recall the following fact from last time, that if I have two events E and F that are disjoint, then the probability of E union F is the same as the probability of E plus the probability of F. And this is a consequence of axiom 3, right? So the proposition that we are looking at now is saying the following: the probability of E union F is probability of E plus the probability of F minus the probability of E intersect F. So this proposition is a generalization of this fact. Okay, when A intersect F may not be empty, E and F may not be disjoint, right? Okay, so I have given you a picture, a Venn diagram right here. So we have the events E and F, and the intersection of E and F is also labeled. And so notice that the way you can get an intuition about this equation is that when you are adding the probability of E and the probability of F on the right hand side, you have double counted the probability of E intersect F, because E includes E intersect F and F includes E intersect F as well. So by adding P of E and P of F, you have double counted P of E intersect F. That's why you're subtracting it out. Is that making sense? Okay, so any questions on that? Anybody? Okay, so let me do an example. Okay, so this is stuck again. All right, so well, maybe we can first of all prove this and then move on to the example. So how would I prove this equation? Anybody has any idea? So let's say proof notice that we could say that the probability of E, E is, notice that E is the union. E is the union of two things, right? E is, you can think of E as E intersect F union with what? E minus F, right? Which, so E minus F. You agree with that? E minus F is the same as E intersect F complement, right? So here E minus F is E intersected with F complement. So notice that E intersect F and E minus F, they are disjoint, right? So in terms of my picture, is it clear which portion of the diagram is E intersect F and which portion of the diagram is E minus F? Let me use green here. So this portion here, right, that green portion is E minus F, or E intersect F complement. So this is the probability. These are disjoint, right? So I can say this plus the probability of E minus F. Is everybody okay with that? Any questions on that? You guys are okay with that? Why can I just add E intersect F is disjoint from E intersect F complement, right? The green one and the intersection, they are disjoint, right? You guys are okay with that? Okay, so remember what I want to get though is this, right? I want to show the probability of E union F is the probability of E plus the probability of F minus the probability of E intersect F. Right? That's what we want to get. Okay, so what is the probability? Let's say, what's the probability of F in a very similar way? The probability of F would be what? In a very similar way, the probability of F will also be the probability of E intersect F plus the probability of F minus E, right? Right, what is F minus E? F minus E is the pink region, right? F minus E. Okay, so here I have the probability of E is that. So from these two equations, what can we get? What can we get from these two equations? Well, let's add the equations. So I get the probability of E plus the probability of F is equal to, and I'm going to write it in this way, the probability of E minus F plus the probability of F minus E plus the probability of E intersect F plus the probability of E intersect F. Is that what I get if I add the two equations? Right? Okay, what can you say about these three terms? What can you say about these three terms? Now notice that E minus F is the green region, right? E minus F is the green region. F minus E is the pink region. F minus E is the pink region, and E intersect F is the intersection of E and F. Are they all disjoint? They are all disjoint, aren't they? And what is their union? What is the union of the green, the pink, and the intersection of E and F? What's their union? So notice E minus F, F minus E, and E intersected with F, they are all disjoint, those three. And their union is exactly what? What's the union of E minus F, F minus E, and E intersect F? Union of E and F, right? So this is equal to the probability of E union F, right, plus the probability of E intersect F. This is the probability of E plus the probability of F. So the probability of E union F is equal to the probability of E plus the probability of F minus the probability of E intersect F. And that was exactly what we needed to show. Okay.